splitting up 7 divided by 2 to be 3 plus a half.
I can get more simplified.
Because remember, if we're adding exponents, when do you add exponents?
When the powers multiply.
When the bases are the same and you're multiplying powers. So we're not going to leave this as 3 plus a half. We're going to leave this as 2 times 5 to the 1/2 times x to the, say it louder, third times x to the 1/2. Notice we're multiplying those powers with those same exponents as what was being added.
I need to write that part.
What do you mean? Just erase? I can rewrite over here for you if you want. Okay. So, am I done? Why not? Well, I mean, do I currently have it exactly the same as how Tia had it? I mean, they were the same starting expression. So 2 times,
X cubed.
notice those are no longer roots.
So no
Times,
first.
not to the first,
To the half.
but they have different bases, right?
5x.
You could say 5x, all being raised to the 1/2. You see how we're raising both those things to the 1/2, which raising it to the 1/2 is the same as which root?
Square root.
So is this expression the same as this expression?
Yes.
No.
Yes, it is.
It's half.
So remember though, Alan,
The square.
the rational exponent is a root. This is 5x to the first and then a square root. The square root of 5x to the first.
Okay.
You see how those are the same thing?
I can't remember what they're called. But the side pieces make it look different.
But you know these portions?
Yeah.
So I mean, it's just they're both roots though. One is just as a rational exponent, one is as a radical.
So they're still the same.
They are still the same.
Okay.
So when simplifying with a rational exponent, what was the first thing we had to do? Did we have to worry about factoring with the variable? No, we did need to factor the, what's the number in front of the variable called?
That's what it now.
The base.
Yeah.
The number in front of the variable.
The power.
How about the coefficient?
Well, yeah, I've never heard this one. That's the first time.
You've never heard the word coefficient?
Nope.
He has, but that's, yeah.
Look, do you see the number that's being multiplied by the variable? The number being multiplied by the variable is called a coefficient.
I had no idea.
Okay.
But it's a number.
It is also a number, but if it's being multiplied by a variable, it is a coefficient. So we had to factor the coefficient there.
Okay.
After we factored the coefficient, what did we do? Converted the, well, we converted to an exponent. What did we convert to an exponent?
The root.
So converted the radical
Cool.
to a rational exponent. But what did we know, or how did we know to do 2 divided by 2, 1 divided by 2?
Square.
I mean, there's no square on the 1/2, on the 5 to the first, or x to the 7th.
Well, you take the root, the index.
There we go. The index of the root became the,
The exponent.
there we go. Convert the radical to a rational exponent such that the denominator was the index from the root. After that, we divided the exponents. So either an integer, well, yeah, an integer, or remainder. All right, so we had either an integer or a remainder, right? X to the 3 plus 1/2. Trying to think of how to better word that. Sorry. So the exponent was either an integer or an integer with a remainder. The final step that we had there was that, well, actually, what did we do? Because this is critical for you to realize. How do we go to x to the 3 plus 1/2 to x cubed times x to the 1/2? Anybody?
How do we go from
When there was a remainder, right? Right here. How did we go from this to this?
well, we just basically, that's adding, and they have common bases.
So we
you
split it up into two.
Different powers.
Okay, when there was a remainder, use x to the m plus n equals x to the m times x to the n to split into two powers. And we simplify from there. Here's the issue though, guys. That's a lot of steps to be memorizing, especially if you don't understand what we're doing. We've got to understand things. And I will say that there is one thing that I would do before all of these. This is why I left an A up there. When I look at the cube root of 16xy to the 5th divided by x to the 7th y squared, anybody have any predictions of what I would do even before I start any of those steps?
Oh,
Like,
God. I remember starting on this. I tried to, I'm gonna do the power rules first and then split it up.
So use exponent rules, and this is for both of those. So if possible, use exponent rules to simplify first. I would not start with this expression. I would start with the cube root of 16 times x. What would x?
Times.
No, I need the x. What's the exponent for x right now?
1.
Right, but I'm dividing by x to the 7th.
Yeah. Times
hold up. Have you taken care of the division by x to the 7th?
Negative 6.
So how did you get negative 6? When you divide numbers with the same base, subtract those exponents. 1 minus 7, okay? Y to the, how'd you get that though?
5 minus 2. Do we have to do the 1 minus 7 and
Yes.
4 minus 2? You can't solve it first?
You're not solving anything. You're not trying to find what makes an equation or an inequality true. What do you mean solve?
Like,
It means
but I
you
just
have to write
put-
it out.
I put x to the negative 6.
So do you have to show your work?
Like, you didn't have to, like,
Yes.
Look, you can not show your work, but I promise you it is much harder to make a mistake showing your work. That's a step that you don't necessarily have to show, but McKay, I've seen way too many people mess it up because they're not showing all their steps. Attention to detail matters. But what I want you to notice is what's going to be more complicated? Working with this simplified expression or what we started with? What we started with is way more complicated. Simplify first. Now, with Tia's method, rewrite 16, that's 2 to the 4th, x to the negative 6, y to the 3rd. Now, this can get a little weird, but notice a cube root really can't cancel a negative, so you may actually need to convert it back to a negative exponent. Really is telling you to do what? Divide, so 2 to the 4th, y cubed divided by x to the 6th.
Okay.
That works.
A negative exponent is really telling you to divide, isn't it?
yeah.
Okay? So then x to the 3rd times x to the 3rd. So now I would start to split up. Cube root 2 cubed times the cube root of 2 times the cube root of y cubed. And then let your inverses cancel.
I got a question.
Sir,
Would it be easier to do it that way or the way I did? I just put it all in their own radicals.
say that one more time.
Would it be easier to just make it one big, long radical? I started it with
I think that'd be easier. Let me show you your homework and I'll write Tahani's strategy on the board in a second. Just finish the set section. We'll look at the go section tomorrow. This will be for an accuracy check though.
Huh?
I would recommend trying to work that Tia's method out before you come to class tomorrow. Actually, let's say that. Finish the set section and Tia's method, or Tahani's method. For last root. So you need to finish the set section and do Tahani's method for homework. Brayden, since you don't have this, don't worry about that, but try Tahani's method for that last root. Did that seem familiar? Have you done that stuff before? Right. Yeah, I don't know what all that is. So why did y'all move here though?
for my dad's job.
Okay, what does he do?
He just told me.
Okay.
We're